Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillahilladzi hadana li hada wa ma kunna linahtadiya laula an hadanallah. Asyhadu an la ilaha illallah wa asyhadu anna Muhammadan abduhu wa rasuluh. Allahumma shalli ala Muhammad wa ala alihi wa ashabihi wa man tabi'ahu bi ihsan ila yaumiddin, amma ba'du. Okay, student, today we discuss about mathematical modeling in process control. But mathematical modeling in process control. Mathematical modeling in process control. Firstly, we ask you, what is the modeling? What is the mathematical modeling? What is the mathematical modeling? I can illustrate you. Here we have the experimental setup. We have the experimental setup. We have any experiment, and in this experiment equipment we introduce an input. We introduce an input and then we get the output. Here we get the output here. Can we make mathematical model to represent this experimental setup? Yes, we can. We can make mathematical model that represent the experimental setup. Okay. Yes, we can. And into our mathematical model, we introduce the same input that we use in experimental setup. And then we'll produce any output by the mathematical model, by the model, using the same input. Yes, look at this, using the same input. The input that we use in experimental setup, we use the same input into the mathematical model. That in here we make the mathematical model that represent the experimental setup. So then the experimental setup produce output, and the mathematical model produce another output too. That is another output producing by mathematical model, produced by mathematical model. When this output is close enough, we can say that the mathematical representation of process that we have, or the mathematical model, is the good model. When this close, we call the good model. So the model, mathematical model, is the mathematical representation of a process. The mathematical representation of a process. That the mathematical representation of the process, that model or that mathematical equation based on the real process. Based on the real process. Okay? That is the mathematical modeling. We use a mathematical model to represent the experimental or setup, the experimental setup, or to represent a process based on the real process. Okay, that is the mathematical model. And then we have a question. Why we make mathematical model? Or what is the use, what is the purpose of the mathematical model? Okay, the use of mathematical model in the use of mathematical model in process control. Firstly, the use of the mathematical model, firstly, is to understand the process, behavior. What does it mean about the process behavior? We can illustrate to you. We have a model. That is the model of the process. And then we giving to the model any input. And then from this model, when we solve this model, will produce an output. Okay. In this year, we will know the condition of the process from a startup into the steady state. From startup into a steady condition. Steady state condition. Steady state. We can see the behavior of the process when we change the load variable or we change the input, the variable of input. When we change the variable of input, or we can call this as load variable. Okay, we have two types in input variable, that is the load variable and manipulated variable. The manipulated variable comes from the load variable. The load variable that we adjust to control is manipulated variable. So we can assume the input variable is load variable. What has happened when the load variable is changed? When the load variable is changed, we will see the startup. From the startup, we will see any transition condition, and then the process going to steady again. This is the steady state, the first condition, and there is the steady state in the second condition. So we can see here, when we change in load variable, the process will show us the transition condition before the process going to steady again. So that is the behavior of the process. What happened when we change in the load variable? What happened in the process? We can see this, the transition condition, and then going to into steady again. So that does mean the process behavior. So we can change into any load variable without using the experiment. Just use the model. So we can make experiment inefficient because we just use the model, not use the experimentals. Okay. That mean is the process behavior. So through this model, we can get the good understand about the process behavior. Especially, we can see the transition condition and then how the model going to steady state when disturbed by changing in load variable. Okay. That is the first using of the mathematical model. And the second, we can use the process model to train the operator personnel, the operating personnel. We can use the process model to train the operating personnel. To train the operating personnel. The model used to training the operating personnel without running the experiment or without running the plan. Just use any model. Suppose here we have a model from earlier. We have a model here. And in our model, we have the input and we get the output from this model. In any condition, we suppose error in input. For example, when the pump is fired to deliver any stream fluid, to deliver any fluid in, to deliver any fluid or any stream, any fluid. We can imagine here, when the flow is, when this pump is reflux pump. In distillation, for example, we have this pump is reflux pump in the distillation process, and when the pump is failed to deliver any flow into the column, maybe we will get the situation, the column in the minimum reflux ratio, minimum reflux rate, minimum reflux rate. What happened when we got the column in minimum reflux rate? What happened? That is the emergency situation. Emergency situation. This is the emergency situation. So we can train the operator to act any action to solve this problem without running the plan or without running the process, like in this scenario. So we can use the model to mitigate any error, any emergency condition without we running in real system, in real process, because maybe we didn't get the permit to run our process in this situation, in minimum reflux ratio or in minimum reflux rate. We can do this in the real process, but using this model, we can do this, and we can train our operator to decide what will they do when they face the emergency situation like this. That is the use of the process model, and the second use of the process model. Okay, fine. In the third, the using of the process model is we can selection of control variable pairing. We know in earlier we have studied about the type of the variable, and we have the two variable that always in pair. That is the control variable, and pairing into this control variable is manipulated variable. Using the process model, we can study the pairing variable or the best pairing variable when we want to control any variable. For example, we want to control the temperature. What will we do? What will we maintain any variable to control the temperature? Maybe the flow rate of steam. That is the pairing of the variable. And we can study about the pairing variable using the model process. Okay? That is the third using of the process model. And then the fourth use of the process model is to develop the model-based controller. That is the advanced control system. We want to advance our control system, and we can use the model process to design the complex control system like this. And you can identify this, the process, the model piece. That means in this control system that we design, we just use the model process, not the real experiment or the real process. So we just use the model process. We can design any control system based on the model. Again, it is clear enough about the model-based controller. That is the use of the process model. And the fifth, the using of the process model is to optimize the process condition. Optimize the process condition. When we want to use the process model to optimize the process condition, we need the two information. Firstly is the process model itself, the process model, and then the second we need the economic information. We need the economic information. So from this information, we can design the optimum, the maximum profit, or to minimum cost. Okay, that is another using of the process model in control system. Okay, we resume again. The use of the process model is firstly to understand the process behavior, and then to understand the process behavior, and then we can use the process model to train the operating personnel without running the real system, without running the real plan. And then using the process model, we can use this model to selection of the control variable pairs, the best of the control variable pairs. And then we can use the process model to design the advanced control system based on the model without in the experiment, the real experiment or the real plan. And the last, the using of the process model is to optimize the operating process condition. Optimize the operating process condition. The operating process condition. So to optimize the operating process condition, we need the process model itself and then the economic information to make the optimum, maximum profit or minimum cost. Okay, that is the using of the process model. And then we continue to the next topic, that is about the classification of the process model. The classification of the process model. Classification of the process model. What is the classification of the process model? How we classify the process model from the how they are obtained, from the how they are obtained. What is the data? Data is the process model. How the process model are obtained? Okay, we classify the process model from this statement. Okay, the first way of our classification is the theoretical model. Theoretical model. The theoretical model is the model that construct from the principle of conservation. Principle of conservation. That is, can be conservation of mass, conservation it can be conservation of mass or mass balance, and then conservation of energy, and then the conservation of momentum. Okay, we use the three conservation laws to develop our model. The model that developed by the principle of conservation is called as the theoretical model. Okay, fine. And then the second model, the second classified of the model is the empirical model. We say this the empirical model. That is the empirical model. That is the empirist model. This model is obtained by the fitting experimental data. By the fitting experimental data. What does it mean about this statement? The empirical model is the model that constructs by fitting the experimental data. We know this. We have the experiment. We set up the experiment, and from this experiment, we get the data. From the experiment, we get the data. And we propose any model. For example, the model is the linear model, the polynomial model, or the exponential model, maybe exponential model. And then from this, we have the experimental data. We have for example, we have the data here. We have the data here that come from the experiment, and we propose any model using, for example, is the temperature of function of the x, for example, a x power of second, and then p x plus c, like this. we have here the model. That is the model. The model where we propose, and we have any data. Data come from the experiment and from the experiment. So using the data, we can calculate the coefficient. What is the coefficient of? We can calculate the coefficient of A, B, and C by fitting the data into the model. By fitting the data into the model. So here we have the data, the temperature, and the X. That is the data. And we can calculate the in fitting data system. Maybe we use a curve fitting, or I think you familiar with the SSE. You know what is? Sum square of error. Sum square of error. That is the curve fitting, or that is the fitting data to evaluate the coefficient of our model that we propose to the data of the experiment. So the model that come from this method to obtain it called as the empirical model. This is the empirical model. Do you know about this? Okay, that's fine. Okay, and then the third model is semiempirical model. What is the semiempirical model? That is the combination of the theoretical model and the empirical model. Okay, that's fine. That is the classification of the process model. We have three classifications. The theoretical model, based on, we construct this model based on the principle of conservation. The principle of conservation of mass, the principle of conservation of energy, the principle of conservation of the momentum, and from this conservation system, when we construct the model using this conservation system, so the model that we get from this obtained method is called as the theoretical model. And then we can construct the model by fitting the experimental data, by fitting the data of the experiment, and then we propose any model using the linear model, polynomial model, or exponential model. Maybe the popular model is polynomial, and we use the data to evaluate the coefficient of our model. The model that comes from this method is called as empirical model. There is the illustration of the empirical model. We have the data here, we have the experiment, and from this experiment we have the data temperature versus X. Maybe this is the length or the length. Maybe we have the temperature versus X here in the data, and we evaluate the data using any method like SSE, sum square of error, like curve fitting system in numerical concept, this, and then we evaluate the ABC, that is the coefficient of our model. This is the model that we propose to evaluate this data. when we propose this model, might be in power second, might be in power third, ax power of 3, x power of 3, and then b power of second, and then yesterday. What it is, and then we evaluate the coefficient. From this, we evaluate the coefficient using the data by fitting data into the model, and the model that come from this method, when obtained using this method, we call this the model as the empirical model. The empirical model, that is the empirical model. And then the last, the model is the combination of the theoretical model and empirical model. We call this the model as the semi-empirical model. Can we call this semi-theoretical model? Maybe can, but this is not preferred. Somebody prefer call this semi-empiric model. Okay, that's fine. That's all. Thank you for attention. We will discuss in depth to develop the model. Maybe we will use any case by case study, and I will show you how we develop the model and how we examine our model, or how we running the model. Maybe you can use, I think you have to install MATLAB, or I like you use not MATLAB. I like you use like Skylab to evaluate our model. Skylab. Please find this software and install into your computer. Maybe I will give the model in Skylab, or you can use the SkyCourse. I will give you tutorial to install and to use the Skylab or SkyCourse in my class in platform in software simulation, I think. And you can join this class, and that is the open class. Everybody can join this class in my platform. Before I use my platform, and the new platform is the myscology.it. Okay, thank you for attention. See you next. Assalamualaikum warahmatullahi wabarakatuh.